Hello friends, welcome back to the channel. Today I would be discussing on a topic that is draft DSM regulation 2024. These regulations were notified on CRC website on 25th, sorry, on 30th April 2024, and the comments were invited on these regulations by 25th May 2024. Recently, many changes have been made in the DSM regulations. So these were the new changes. In this regulation, the frequency band in which the system will operate or try to maintain most of the time will be between 49.90 to 50.05. So let's begin. What is there in the regulations? And in this regulations, in this video, I would be discussing mostly on the generators part and how the changes are there in comparison with the earlier regulations. So let's begin. So before understanding what are the changes there in the regulation, let's be clear about certain terms and definitions which are needed to be understand to explain the regulations in detail. The first of the term is the reference rate. The reference rate is nothing but the cost of the energy, or basically the price at which the supplier has agreed to supply the electricity per unit to the beneficiary state. Then it's a renewable rich state. Renewable rich state means a state whose combined installed capacity of renewable generating station is under a control area is between 1000 megawatt to 5000 megawatt. And then the renewable super rich state, a state whose combined renewable capacity, including both solar and wind, is above 5000 megawatt. So these are the three terms which is there. Then the next term is the deviation rate. The deviation rate will be calculated by sum of three components, that is the day ahead market rate, the RTM rate, and the ancillary charges. Uh, all three will contribute 1 by 33%. For example, suppose a day ahead rate for a particular block is 10 rupees and RTM rate is 6 rupees and the ancillary rate would be suppose again 10 rupees. So the deviation rate for that block would be 1 by third of all the three, that is 10, 1 by third is 3.33, then 6 divided by 3 would be 2, and again 10 divided by 3, that is again 3.33. So the total cost would be almost 8 rupees 66 paisa for that block. So this is how the deviation rate would be calculated. And in absence of ancillary rate, the dam rate and the RTM rate would be given a weightage of 50%. That is 50% of the dam rate of that block and the 50% RTM rate of that block. Sum would be used as the deviation rate to calculate the deviation rate of that block. And in absence of even any one of the above component, that is dam rate or RTM rate, then the previous day dam rate of that block would be considered as the reference for the calculating the deviation rate of that block. So this is how the deviation will be calculated. So I think you should be clear with the term of reference rate, deviation rate, and the two other terms, that is renewable energy state, renewable rich state and renewable super rich state. So in these regulations, I would be mostly using the term reference rate and the deviation rate. Other two terms, for other two terms, the regulations have been placed this year or in these regulations. But for normal thermal generating stations, only the first two terms would be considered useful. So let's talk about the regulations now. So let's understand the basic crux of DSM regulations. Through DSM regulations, the CRC has already tried to maintain the frequency at 50 hertz, and any deviation from the schedule generation which you have been given, if you do any deviation from the schedule, you would be penalized, provided you are not supporting the grid. For example, if the frequency is less than 50 and you are injecting something, that you would be given a incentive for that, and similarly if the frequency is above 50 and you are injecting, then you will be similarly given a certain uh, benefit on that, and vice versa. If you are frequency less than 50 and you are under injecting, then you would be given a penalty, then you have to pay a penalty. And similarly, if the frequency is above 50 hertz and you are over injecting into the system, then you will have to pay certain penalties. Now this is the basic DSM regulation which have been in place, and through this the DSM regulations, the CRC had tried to maintain the frequency within the nominal band. So what's the new regulation which is making them different from the earlier case? In the earlier case, for example, if I discuss the last regulations or the DSM regulations which are in place presently, there is a basically a dead band of point uh, 0.9 hertz, you can say, that is 49 from 49.94 to 50.03. Within this frequency band, even if you under inject or over inject within a margin of 10% of your schedule generation or 100 megawatt, whichever is less, you don't have to pay any penalty. So if you are even you are under injecting or you are over injecting, so you don't have to pay any penalty. But beyond 49.94, means less than 49.94 band and above 50.03, if you deviate from the schedule and that deviation is not supporting the grid in any way, then you have to pay certain penalty. But within this regulation, the major change which has been placed, which has been done, is that that band has been removed. Now, even a zero point zero 0.01 hertz deviation will be considered as an opportunity, as well as the even as well as the penalty if you are under injecting from the schedule. So let's discuss one by one. The case one is when the frequency is between 49.90 to 50 hertz, means less than 50 hertz, and even at 49.90 considering, even if you under inject by 0.01 hertz, then you have to pay a penalty of 5%. And if you if you under inject and sorry, if the frequency deviation is 0.02 hertz from 50 hertz, then the penalty would be 0.1%. So any deviation from frequency from the scheduled generation by 0.01 hertz, you have to pay a penalty of 5%, and that penalty keep on increasing. At 49.90 hertz, it's become the maximum of that is 50%. So if at 49.90 hertz we are under injecting as a thermal generator, then we have to pay a penalty of 50%. So this is how the penalty would be placed for underjecting in case the frequency is less than the 50 hertz. Now in the second case, we will talk about when the frequency is between 49.90 to 50.05. So sorry, that's when the frequency between 49.90 to 50 hertz. In that case, if we over inject, what would be the incentive which we are getting? In case 2, as discussed earlier, if the frequency is between 49.90 to 50 hertz and we are all injecting in order to support the grid, then will get an incentive of 1.5% of my fuel cost. So and similarly, if the frequency goes by 0.02 hertz deviation, that is 49.98 from 50 hertz, then the and we keep on over injecting, then the penalty then the sorry then the basically opportunity would be 1.5% into 2, that is 3%, and this goes on increasing. It goes up to maximum 15% at 49.90. So at 49.90, if as a thermal generator we keep on over injecting in order to support the grid, then we get a maximum incentive of 15% from on the fuel cost as the gain. And the illustration has been shown keeping the fuel cost as 5 rupees. So if you can see that as the frequency dipping and the keep, even if the margin is our injection is by 1 unit, the profit is increasing up to 15%. So in comparison to the previous regulations, the profit or the opportunity or the incentive, I would say, for deviation is 50%, which has been reduced to just 15% in the present scenario. Now we will discuss the next case when the frequency is above 50 hertz, and what would happen if we over inject. And in the next case we will discuss when the frequency is above 50 hertz, what will happen we under inject. And in the final case we will discuss about the scenario when we when the frequency is less than 49.90 or above 50.05, how it will affect the system. So if the frequency is between 50 hertz to 50.05 hertz, and for every increase of zero point zero 0.01 hertz, then the charges for deviation for such generating station, if they are on injecting, would be 10%. For less than 1450 hertz, as you remember, the deviation charges would be 5% for under injection. But here in our injection, if we deviate by zero point zero 0.01 hertz in the upward direction from the 50 hertz, and the system is continuously over injecting, then that deviation would charges would be 10% of the fuel cost. So at 50 hertz, 50.05 hertz, the deviation charges become 50%. That is 50% penalty we have to pay for over injecting at 50.05 hertz of the reference charges. For example, the reference charge is 5 rupees, that is the normal ECR is 5 rupees. So if the thermal generation generating system is over injecting even by 1 unit, then it has to pay 2.5 rupees as the penalty. Now, above 50.05 hertz to 50.10 hertz, the charges would be zero. That is, we don't get any payment for our we don't get any uh, ECR charges if we continuously over inject above 50.05 hertz. Means the deviation charges would be 100%, and above 50.10 hertz, then we will not get any charges for our fuel cost, or we will, or I would say we will not get any fuel cost. Additionally, we have to pay 10% of the fuel cost as the penalty also. Let me explain you further in this. For example, uh, let's talk, we are our injecting 100 units and the frequency is at 50.50 hertz. So at 50 hertz, we are getting the fuel cost as the our injection cost, or I would say, suppose I'm injecting 100 units, so I would be getting 100 for 100 units as the fuel cost. The grid is returning to me. At when the frequency becomes 50.01 hertz, then even we are over injecting 100 units, but the grid will pay me only 90% of our fuel cost to us. So 10% is our statewide loss, and this loss continuously keep on increasing. At 50.05 hertz, the loss become 50%. That is, for our injecting of 5 rupees, we would be getting paid only 2.5 rupees. Now, if the frequency moves to 50.06 hertz, the grid will not pay us any money. And similarly, it goes on to 50.07 also, the grid will not pay us. 50.08 also no payment to us. At 50.10 and above, at 50.10 and above, if we continuously inject 100 units into the grid because of the any reason, then the grid will not pay us anyone. Also, in addition, we have to pay a 10% of our fuel cost as the penalty. Means our loss would be, considering the fuel cost of 5 rupees, would be 5 rupees 50 paisa. So that is the per unit loss a thermal station has to bear if it continuously over inject at 50.10 hertz, provided the fuel cost is 5 rupees. So let's take the example when, or the case study when the frequency is above 50 hertz and less than 50.05 hertz, or even at 50.05 hertz. If the thermal generating station under inject, then its deviation charges will be reduced by 3% of the fuel cost. So let's understand this case study in broad. For example, a thermal generating station is under injecting 100 units at 50 hertz. So the 100 units which the thermal generating station under inject, he will get a fuel cost for that. But at the same time, he has to pay a deviation charge of 100 into 5, that is 500 rupees. So he will get a fuel cost of 500 rupees. So he will save a fuel cost of 500 rupees because he is under injecting from the schedule. But at the same time, he has to pay a deviation charges of 5 rupees. So no profit, no loss. As the frequency increases by 0.01 hertz, the incentive for the generating station is that at 100 units under injection, then the penalty or the deviation charges would be 97% of the reference rate. That is 4 rupees 85 paisa. And the 100 units he is under injecting, so he has to pay a deviation of 4 rupees, 485 rupees only. So the 15 rupees would be his incentive for supporting the grid when the frequency is above 50 hertz. And as the case earlier, this deviation charges will be keep on increasing with frequency. Means at 0.02 hertz, the deviation charges will be 6%. Sorry, the deviation charges would be reduced by 6% of the reference rate. At zero point zero 0.03 hertz, the deviation charges would further reduce by 3%. So at 50.05 hertz, the deviation charges would be reduced by 15%. And this figure becomes flat, means even at 50.05 hertz, if a thermal generating station is under injecting, then he has to pay 15% less deviation charges for the units which he is under injecting. So in comparison with the earlier regulations, the major change is that the incentive for supporting the grid has been reduced considerably. It is plus minus 15%, means but in the earlier case it is plus minus 50%. Now let's consider the next scenario when the frequency is above 40 below 49.90 and above 50.10 band. How does the charges or deviation would vary? Or if the generating station deviates by more than 100 megawatt or 10% of the scheduled generation, whichever is less, in that case, what would be the deviation charges? The major change which has been brought in this regulation is that earlier in earlier regulations, whenever you deviate from the schedule and that deviation in addition combined with the frequency, and you are actually supporting the grid by either over injecting by any amount above 49 or less than 49.94 hertz, and by under injecting any amount above 50.03 hertz, you would be incentivized, and there is no limit on the amount of support you can provide. But with these regulations, the major change is that the CRC has clearly told or written that any deviation about 10% or 100 megawatt, even if you are doing it in order to support the grid, that would be uh, not incentivized. You may not be penalized on that, but that would not be actually incentivized. So it's better that you should come within the schedule generation or within the deviation margin of 10% or 100 megawatt, whichever is less. So let's take the example one by one. Suppose uh, frequency is less than 50 hertz, and a thermal generating station is deviating by 100 megawatt or 10% of the scheduled generation, whichever is less. Then in that case, he has to pay a penalty of 150% of the reference rate. That is, his reference rate is suppose 5 rupees, then he has to pay a penalty of 7.5 rupees per unit for the amount he is under injecting. If the frequency is between 49.90 to 50 hertz, and if the frequencies goes below 50 hertz, 49, sorry, if the frequency goes below 49.90 hertz, then that deviation charges would be twice the fuel cost. Means he has, for the thermal generating station has to pay a 10 rupees penalty if the fuel cost, considering the fuel cost as 5 rupees, for under injecting of 1 unit. Means his losses would be 100%. And similarly, if the frequency is above 50 hertz and the thermal generating station tries to under inject by 10% or more amount, 10% or 100 megawatt, whichever the more amount, then he would not be paid any extra money. Instead, the charges of deviation would for him would be at the reference rate, that is 5 rupees in this example which we have considered. Now let's take the case of over injection. Suppose thermal generating station is over injecting by 10% or more, and suppose the frequency less than 50.1 hertz, or any frequency less than 50.1 hertz, then for amount under injecting, he would have to, sorry, for the amount over injecting, he has to pay the deviation charges. Sorry, his deviation charges would be zero, and his over injection loss would be at 5 rupees. And if the frequency is above 50.10 hertz and the thermal generating station is over injecting by any amount, then he has to pay the fuel cost. In addition, he has to, sorry, he would not be reimbursed his fuel cost, as well as he has to pay 10% extra fuel cost as the penalty. So his losses would be 5 rupees 50 paisa, considering the fuel cost of 5 rupees. So these are the basic major changes which have been done in these regulations, and I hope you would be clear with the draft DSM regulations 2024, which have been tabled by the CRC on 25th April, sorry, on 30th April 2024. So if you have any comments, please mention the comment section. I would try to respond to your queries, and till then, have a safe day. And if you like the video, please press the like button and do subscribe to my channel. Thank you.